Thank you so much for having me, Mark. And in the spirit of people not being able to find out all the things about me and me having some surprises up my sleeve, so that introduction needs a slight update because as of yesterday, just a couple of months shy of my 10-year mark at Google, I have actually gone solo. So I guess I can say that I'm a founder now. So yeah. It feels weird to say it after 10 years of having that identity at Google, and I love the company very much, but yeah, it's time to do some fun new things. But let's talk about, oh, do we have my slides up? If I just keep clicking, or? Nope. I'm revealing all the secrets. I'm revealing other people's secrets. I gotta stick to my own secrets here. Can we switch the slides? Okay, so let's talk about the secret to AI innovation and level set a little bit here so that the rest of the day makes perfect sense to everybody. So first I'm going to say a spicy thing about today's AI revolution. And by today's AI revolution, I mean the one that's been going on since about November. Right, the ChatGPT, generative AI type of revolution. And here's what I'll say about this AI revolution is that it is not an AI revolution at all. To understand it, you should understand it as a UX design revolution. That's actually what's going on. But let me not get ahead of myself. Let me build up to this gently. Very gently, from the very basics. So what the hell are computers for? We know this. They turn inputs into outputs. And how do they do it? Via some code, some model, some recipe. And the difference between traditional programming and then the machine learning and AI bucket is simply where that recipe comes from. So forget all this stuff about the robots, Terminators, all that kind of thing. The real difference here is simply the source of the recipe that the computer will then use to turn inputs into outputs. So how do we get it in traditional programming? So in order to automate a task, what does a programmer do? They sort of communicate with the universe, they meditate hard upon the problem, they have to know how to do the task. And then they write up these instructions to tell the computer what to do. So what do you do if you don't know how to do the task yourself? If you don't know how you're doing it? How do you automate that? How do you write the instructions? Very, very difficult. So where does that recipe come from in machine learning and AI, if not from handwritten instructions? It comes from examples. So take a task, a very classic task, like show a computer an image, and it has to decide whether that image has a cat or not in there. That is a very, very easy task for all of us to do. But it's very difficult for us to explain how we're doing it. I mean, look at these images. What did your brain do with every single one of those pixels to get the answer? How do you describe that? What is catness? It's difficult. So you don't have a really good chance of getting that done by trying to work out the instructions by hand, figure them out, and write them down. But you could take a crack at using examples. And I like this word examples because it takes us away from the word data. There are synonyms here. But I feel like people tend to pronounce data with a capital D and then lose all common sense. So what we're really doing here is we are communicating with machines a second way. When we try to teach one another how to do something, sometimes we use explicit instructions, sometimes we use examples. We say, here, watch me do it a few times. This is the right way to do it. This is the wrong way to do it. And then you figure out the pattern, you come up with the recipe for yourself, and off you go. So really, what this is a communication revolution. It's not scary robotsy stuff. It's really what we wish we could have done with machines all along. And back when, many decades ago, in the early days of AI, I love this hubris. It's human hubris is just so great. But a whole bunch of early AI researchers put in a grant request to spend one summer to work out this whole AI thing, right? They were going to get it in one summer many decades ago. To have that second mode of communication, to be able to use patterns and examples for programming computers versus explicit instructions. Because we always should have had those two modes. But it took us a while to get there. And now that we finally got there, people are freaking out at all the things that we can automate. That really, you know, if we had managed it sooner, before all the sci-fi films and books grabbed our imaginations, we would have been deliciously bored by all the buzzwords and so excited by all the things that we can achieve. And what I also love about this space is that human language, it evolves. And now people are talking about AI in, I would say, at least 3 different ways. Add a 4th if you like all that sci-fi stuff, which really we are too sane and professional to put up with in this room, so I'm going to toss that out the window. So 3 broad ways that people are talking about AI. And I love the way that people talk past one another here, because they are not talking about the same thing. And then you have some founders who are like, I'm in the AI space, and you hear that, and you hear that, and you think you know what they're talking about. And even worse, you think they know what they're talking about, which they may or may not. But let's level set here. The way that the language has evolved has gone broadly by decade here. So 2003 and before, where is the epicenter of the AI hype? It is with researchers, and it is all theoretical there. In theory, how might we get computers to pull patterns out of examples and turn them into instructions for getting future tasks done? Not that we're actually going to use it for anything useful, because we're missing some key components. We're missing the actual examples, the data, because it turns out that you need a lot of them, and we're missing all the hardware and software that allows us to move those examples around at scale. So it's all theory. And I also, I struggle with the term artificial intelligence. I love the way in which even psychologists struggle to define what the hell intelligence is. So all the rest of us who aren't actually professional psychologists weighing in on that term and then failing to weigh in on it and using it as if we would know it when we see it. Oh my goodness. So instead of AI standing for artificial intelligence, maybe by the decades, I would say in the researcher's time, AI would have been automated inspiration, pulling an inspiring pattern out of data. How might we do that? Then, a decade later, when we finally got all that hardware, software, and the data to do it, well now, the epicenter of the buzz moves to builders. Researchers are still talking about AI their own way. They are still building those foundational algorithms, that mathematics that gets things done. But there are a hang of a lot fewer of them than all the people that jump on the bandwagon to suddenly do something with it. Because now we can. How amazing is that? And by builders here, I don't just mean the programmers, engineers who are building the technology. I also mean the builders who are building with their wallets. That is where the epicenter of the buzz is. And now, since November, there is a new group, and who are they? It is the users. That's who's talking about this, and they are talking about it in a way that is very confusing. I mean, you'll meet Jan later. He is a great example of a researcher. I myself am an example of an applied AI person. I'm a builder. I was in the research space when I started my career, but I got very much into the building of it. And I imagine that both Jan and I'll speak for myself, I will guess for him, are wildly bewildered by the way in which all the users and newcomers to the space are talking about it. 3 different groups solving 3 different kinds of problems. And so what problems are they solving? Well, theory for the researchers. How might we get this to work in theory? What kind of mathematical algorithms make sense here? Enterprise scale problems for the builders. And this is key, because even though you started being able to do it, you had the data, you had the processing power, that didn't mean it was cheap or easy to do it. So whoever was in the game tended to be solving these enormous monolithic problems that make sense at enterprise scale. You're not going to solve small, custom, individualized problems. Except today, you are. That's the difference. That's the big thing. And so I would say automated inspiration for the researchers, applied innovation for the builders, and augmented individuals, that's the new AI, for the users. That is the revolution. And it is all design, behind the scenes. The foundation models, as we call them, they work according to the same principles that AI has worked for the last decade. So from Google's perspective, nothing new. Same kind of testing, same kind of innovation stages, same approach. But something very different is happening. And that is that AI is being given by the large companies making it to smaller companies being able to tweak and play with it, and to individual users as a raw material, which is something that I will come back to. But the raw material piece is something quite weird to wrap your head around. So let's talk about investing in AI innovation. So I know that there are a lot of investors in the room here, so I want to give you my one favorite piece of advice. And to do that, I need to build up a little analogy to help us all think very simply about this space. And that is a kitchen analogy. Now, you know, don't get excited. I have no idea about kitchens, so I'm just doing my best here. I know a lot more about AI than I do about running, say, a McDonald's scale kitchen. But I think that this is still a great analogy for AI. It kind of maps. The data are your ingredients. Same principles hold. Ask any chef if you can make a beautiful Michelin-starred meal with absolute garbage rotten ingredients, and they will tell you forget it. It's very important to check the quality of your ingredients. And if you're not going to check it yourself, you should know the provenance of your ingredients, and you should really trust whoever made them for you. And there's going to be a whole lot of preparing your ingredients to get them to work properly. Same principles entirely. Now, the algorithms that your researchers build for you, the mathematical bits, they are like all the appliances in your glorious, glittering kitchen. The microwaves, ovens, blenders, etc. And if you are a researcher, you must, of course, understand how that microwave works. Because what are you doing? You are making blueprints for a new kind of microwave that has never existed before. It teleports food right out of the microwave onto your plate, for example. And then if you're a platform engineer, you will go and package up that horrible invention that, you know, is held together by hope and sticky tape. If anyone's ever worked in an engineering lab, I have. Goodness, those things are not user-friendly. Only their mother can love them, so someone has to package that up so that normal, sane humans can use it. And then what the applied AI folk do is they are innovating in the recipes themselves. So maybe your goal is to make a croissant, but it is the most delicious croissant that passes the French chef tasting test, but it is also sugar-free and it's gluten-free. Okay, good luck. Are you going to be able to make that croissant at all, the recipe for such a croissant? You might not. There is no guarantee. But how are you going to go about it? You're going to gather ingredients, you're going to gather appliances, and there is going to be a whole lot of tinkering, a whole lot of trial and error. And you can do that trial and error smartly, which is what I tried to do and what I've tried to help Google do, and you can do that really dumbly in a way that, you know, theoretically you could find the answer, but it'll take you forever and you'll run out of funding. And then finally, when you have that recipe, if you succeed, you're going to test the hell out of it, of course, and then you will start serving dishes, serving predictions, and that's your big enterprise scale system. But now, with the new layer of generative AI and its ilk, we now have data products. We are giving you those standard cookies in this example, and we are letting you take them and turn them into whatever you like. Maybe they are Valentine's Day baskets, and that's your particular individual thing. Or maybe you're going to spray paint them gold and call them art. right? We don't care. We give you the cookie, you do what you want with it. Now, what an incredible leap forward. We did not have this 10 years ago. 10 years ago, take it or leave it, right? Everyone here used Netflix, for example, or Google. The UX principle of the time said, don't even worry if there's AI in there. If you're an AI person, you'll know. You'll kind of see it at the edges. You'll know that the only way that those types of recommendations can be served to you is because there's AI in there. But if you're a regular user, it is an embarrassment, as far as UX designers are concerned, to show you those seams, to tell you, here's AI, look at it. So you would just be using these things in a take it or leave it kind of way. Netflix is solving its own problems, Google is solving its own problems, and its problems is to give you a delightful user experience, hopefully. And you take that experience or leave it. Nobody is saying, here, in your face, take the AI and do what you want with it. What a huge and amazing difference that is. Okay, now that I've level set, here's my one thing I want to tell all investors. If any founder comes up to you and says they do AI, please make them explain to you which part of this ecosystem they are playing in. Because if they claim to be doing the whole thing, forget it. Likely posers. Okay, we try to do the whole thing at Google. It is hard. It is hard at Google scale to do the whole thing. What, 3 people are going to come and play in the whole thing? No way. So get them to tell you which part they're doing. There is plenty of interesting, innovative work that could happen there. It all makes sense in the same way that the kitchen makes sense. Like, are we flipping someone else's cookie cutter outputs into something individual? Are we preparing ingredients? Are we creating new approaches that solve the kinds of problems that couldn't be solved before, very researchy? Are we packaging things up, making it user-friendly? Are we creating new recipes for business problems that had no solution before? Which one are we doing? But please get them to explain it to you, and if they can't, run the other way. Now, I want to get back to the AI as a raw material concept. Going from the solving this one monolithic problem, which, by the way, in terms of trust and safety, is a much easier problem to solve, because something like your Netflix or your Google of the world has a very clear idea of what success looks like, very clear metrics when they solve that one big problem with AI. When instead you say, here you go, here's an AI system, use it however you want to use it, for whatever you want to use it for. How do we regulate raw material use? Who is responsible for raw materials going wrong, being put in the wrong people's hands? It depends on the raw materials. We don't have good regulation standards for this. So everyone's yelling at the regulators, figure it out. Regulators haven't figured it out for physical products, never mind digital products. So this is a nightmare. And look again at this space. Let's say that someone is creating a bunch of cookies, and you're being offered this as a raw material. Use it for whatever you like, go ahead. But you don't know anything about where the ingredients came from, what the ingredients were, what appliances they were put through, what were those recipes in the first place, how did any of the taste tests work, how did we know it was safe, what did we even check it was safe for? You know nothing. Oh, here you go, use it. What a trust and safety nightmare. I love it. So please be careful. Don't assume that AI is something intelligent and it just works and it's going to work well. It's a raw material. You're going to use it. And what are you going to do to keep yourself safe? You're going to trust no one. Any good AI professional knows, trust no one. Don't even trust yourself. Test everything. I mean, on the other hand, why would you ever trust an engineer to come up with a bunch of instructions correctly by what? Thinking about it in the bathtub? No. So you're going to test anything that a human writes in terms of code. You're going to test anything that you might have made the old traditional way. And when you flip somebody's AI model, use that as a raw material for your own use case, of course you're going to test the hell out of that. And where are you going to test it? With your own ingredients and your own settings. So there's got to be a lot more testing. In an enterprise setting, You have control over most of this stuff, so at least you've got some visibility. You kind of know where your ingredients came from, but trust me, you can still do some really stupid things like buy it from a vendor and completely ignore it, not test anything, we've all seen it all. But at least you probably have more visibility into this whole space. Now, you don't. Many things will go wrong, and we've got to prepare for that. But at the same time, there's a pragmatic way to go about it. Don't trust, test. Test carefully. So people ask me, if we're going to get into generative AI, who should we hire? Now, partly a designer, that's a good suggestion. This is a design revolution. Get a designer, figure out what problem's worth solving, make something delightful. So I kind of want to tilt there. But if we're going to be practical, you know who I'd rather go for? A reliability engineer. Never mind AI research, whatever. Why are you innovating in the microwave? You don't need that. And you probably got no visibility into it. But that person who trusts no one and nothing and not themselves, and they've been woken up at night at 3 a.m. many times because the systems are failing, those are the people who are going to have the right perspective on this. Test everything, trust nothing. And then, in my last 3 minutes, let's talk about the most dangerous thing about AI. What's the most dangerous thing about AI? It's you. It is the leaders and decision makers in this space. In traditional programming, if I want to get a task automated, maybe it takes me 10,000 lines, maybe it takes me 100,000 lines of handwritten code. I have to agonize over every single line. And maybe it's not me, maybe it's some other human because I load in someone else's package, but some other member of my species has to have thought about that and asked, is it reasonable and why is it reasonable, and done some unit testing. With AI, there are actually only 2 lines of instructions that you need in order to automate the task. It looks like a lot because the UX of the tools for getting the data in and actually finding the patterns are still very researchery. And they've got that attitude of like, if you can't put up with a horrible tool, why are you here? That's going to change over time. So all the huffing and puffing and the many lines today, that's because it's some nasty software. When the software gets better, what you will see is that behind the scenes there are only 2 lines in AI. So what are they? Optimize for this goal on that dataset, go. Ooh, just like a magic lamp with a genie in it. Highly, highly subjective. What should the goal be? How do we express it? What does success look like? And which examples? You could just say, hey, there's a pile of examples we got from a vendor. We didn't open them, we didn't look at them. Data are magic, right? You could do it that way. That would be a nightmare. Or you could treat it as a textbook and expect that just because the textbook says history on the cover doesn't mean that that's what you want your student to be learning. What if it's written by a terrible, biased, bigoted, horrible individual? Well, just like textbooks, data sets have human authors. The data advantage isn't magic, it's memory. It's much more reliable as memory than whatever goes in your squishy wet stuff, and it's better retrievable than what's in a book. But just like we say, if it's written in a book, it must be true, and then we roll our eyes, it's the same thing with data. So someone has to take responsibility for what does it mean to succeed? What are we trying to do here? And what would be appropriate in terms of the examples? And these are such neglected questions. Is somebody qualified usually tackling them? Because the math nerd is not qualified. And the data scientist loves data, but not necessarily common sense. So who's going to do this? What about leadership? Well, they're trying to punt it quite often to somebody else that they think is more qualified than them on the technical nitty-gritty. This is not technical nitty-gritty. Or it should be, but a different kind of disciplines, technical nitty-gritty, disciplines around decision-making. How do we step up responsibly to the magic lamps that we're building? This is missing in society. It terrifies me. Because these large systems are designed by a few individuals with or without the skills to make decisions of this kind that then affect millions of lives, billions of lives. So this is another A and I, amplified impact. That's what we're having, of decision makers and leaders. And it would be great if we all put the effort in to educating ourselves and making ourselves worthy of leading in this space. Being a little bit more careful, a little bit more thoughtful. What used to be 10,000 lines or 100,000 lines of code we should now take that same amount of thoughtfulness and put it back into those two. What the hell are we doing with it? What is success? Which data? And how would we know if it works and it's safe and it's okay to release upon the world? So I would love to see us starting to focus a lot more there. That is the missing piece. And when we start solving that, I think that we've got the secret to safe, effective, useful AI innovation. Thank you very much.
Cassie, thank you very much. It's really gratifying to know that we're actually investing in automated inspiration and we're investing in amplified impact. So maybe all of our founders will feel very excited about that too. Thank you for your talk, and more importantly, thank you for announcing your new startup here. We didn't expect that, so you should talk to Laurel. We've got a bunch of press back there. I'm sure they want to talk with you. Thank you again.